here we go. Angles and their measures. So, again, things that we're going to do today, you probably did last year. But get your calculators out. So we are going to learn how to convert to degrees, minutes, and seconds, and vice versa. So, all the times that you have done your math and your angles, we know here's an angle, and let's say this is about 60 degrees. Okay, we know that, because that's what we deal with. If this was huge, like a huge angle, I could actually cut that into 60 separate degrees, yes? Okay. So then we could take each one of those degrees that I've separated and cut them into 60 things called minutes. And then you could take each one of those minutes and cut them into 60 sections called seconds. Okay? So when you're looking at an angle like this, it doesn't make much sense to think of splitting it up that many ways, right? But in the big scheme of the world, when you're talking about longitude and latitude coordinates, where you go to degrees, minutes, and seconds, it makes a big difference. Okay? Yes, that's fast.
Are minutes and seconds like a different unit in math?
Yes, it is a different unit. It's now in degree instead of an hour. Yeah, we're not talking time anymore. Okay?
Can you call it something else or sure?
No, I don't know. I did not start this, Sebastian. That's just how it is. I can't go back and change it now. There's lots of things we'd have to change. Logan.
Do you know how accurate a second is?
I do. Do you?
No, I know.
Okay, so that's what I was just going to talk about. Who has done geocaching? Or has anybody heard of geocaching? Okay, it's like a little treasure hunt where you can get the longitude and latitude of the treasure, and you go there, and then you have to solve a riddle, right? Because 1 second is approximately 100 feet. So that longitude and latitude will get you close, but it's not going to get you right on top of it. All right, so they have to give you a little clue. So geocaching is kind of fun, and it's cheap, like it's free. It's a little entertainment for a whole, I mean, they're everywhere. And some of them are like, they put money on them.
Creepers can use there.
Really?
Would be bad.
I don't think many geocachers are those kind of people. Just, what are they going to hide that's bad?
What if what you pick up is a tracker and they can track you?
No, you don't take it.
But then, no, sometimes you can.
Well, sometimes you can, but okay, what are they?
What if you go to find a geocache and
There's bad people.
What are they going to do when they track you?
You know what? I probably could create the Criminal Minds episode of how that works. Here we go. Now we're all on the blooper reel. Here we go. Let's go. Converting from a degree to degrees, minutes, and seconds. So the 37 is the degree. So we're going to start there. That whole number is the degree. And then what we're going to do is we're going to take the decimal part and we're going to multiply it by 60. Get my calculator. You get 25 and a half. So this 25 is going to be our minutes. Okay? And then you're going to take your decimal part and multiply it by 60. And then this whole number part would be your minutes. And if the whole number part, it doesn't matter whether there's a decimal part or not, that whole thing is going to be your minutes. Because minutes could have a decimal.
Was the 25 the degrees then?
No, 37 is the degrees, 25 is the minutes, and then that's the seconds. Okay, so the degree is always that whole number that we start with here. That automatically just goes there. Okay?
I'm confused here by the formula a little bit.
Okay, so you're going to take this whole number, that's your degree part, automatic. And then you're going to take the 0.425, that decimal part of the degree, and you're going to multiply by 60. This whole number part is now going to slide into the minutes.
And do we just get rid of the decimal?
Then we're going to use this decimal and multiply it by 60 again, and whatever's left here is the seconds. Okay, does that make sense? Nothing too crazy hard. if you're going from degrees, minutes, and seconds to a decimal degree, the 42 is the whole number part plus. You're going to take the minutes. How many minutes are in a degree again? 60. Plus, how many seconds are in a degree? Not 60, but 3,600, right? 60 times 60? Because you have 60 minutes in each one and then 60 seconds in each one of those. So if you put that in your calculator, you get 42.41. Okay? So there's two different ways to do this. You can do it by hand, which is not hard, or you can use your big boy calculator. So the big boy calculator has an angle menu, which is the apps key. Do you see it says angle in blue? See that? Everyone looking at the calculator? So if I want to convert this decimal, 37.425, I'm going to bring up that angle menu. So that's the degree symbol, that's your minutes symbol. The R stands for radians, which we're going to talk about later today. And then this little arrow to DMS is converting to degrees, minutes, and seconds. So just hit a 4 and hit enter. So it will convert for you. We didn't waste our time because now we understand better what a degree, minutes, and second is, Sebastian. Chase.
How did you get to 3,600?
You have 60 minutes, and each one of those has 60 seconds. So it's 60 times 60, there's 3,600 seconds in each. Just the same as a time, there's 3,600 seconds in an hour. Okay? All right, vice versa. If you're going to take degrees, minutes, and seconds, and you want to go to a decimal degree, 42, you got to type it in exactly as you see this. So 42, go into your angle menu and hit degree. 24, go into your angle menu and hit seconds, which is number 2. I'm sorry, minutes. And then 36. Now this is the weird part with this calculator. The second notation is not in the angle menu. It is out here where you see the plus sign. You see the double tick mark in green?
Oh, yeah.
You can hit alpha and then plus to get that little double quotation looking mark. I know, $100 and I can't put it in the right place. What? Click. Okay. I personally think it's easier to type this in than to go in that menu every time.
I'm assuming we're not going to be allowed to have these on the test, right?
You will be allowed to have these on the test. Okay? But one of you knuckleheads will forget it and you'll have to use a red one, so if you don't know how to do it that way, it may not be good. Alright? So, there we go. I don't know, maybe for the quiz. I'm not for certain. We'll look. Plus, the trig is going to be hard enough without it, but with the calculator. It's gonna be okay. Alright, what's a radian measure? Can anyone tell me what a radian, I know you learned them last year. The radius is the distance from the edge to the center. What's a radian measure? Kind of, yeah, part of the circumference. Okay, so this is the radius.
Segment of the circle.
It's a segment of the circle, right. So we're going to talk about the radian measure. 1 radian. 1 radian is, see this length? Imagine that I marked it out here. It's 1 radius length around the circle. That's what a radian stands for. 1 radian is the radius length. So if you think about the circle, what's the circumference of a circle? 2 pi r, right? So let's say that the radius is a 1. So the circumference of that circle would be 2 pi, correct? What is that as a decimal? Without that calculator, can you do that without the calculator? What's pi? 6.28. 3.14 times 2 is 6.28 approximately. That means around this circle you can fit 6.28 radiuses. So each one of them is a radian measure. So we're going to say that's 1 radius, that length. There's 2, there's 3, not quite half a circle. A little bit more, that's 0.14 by the way, because 3.14 would be a half circle, right? There's another radius, 5, 6, and then this would be how much? That 0.28 left. So you can fit 6 whole radiuses around that circle with almost a third of a radius left. Does that make sense? So a radian measure, 1 radian, is just 1 radius around. It's 1 radius. It's the length of the radius on the arc of the circle. Okay? But when we're talking about radian measure, when we say, hey, 60 degrees is the same as pi over 3 radians. So here's 60 degrees. Okay? This distance, what's pi divided by 3? What's 3.14 divided by 3? Yeah, something like that, right? So 5. So this length is 1.05, which is a little bit more than my radius, because it's 1.05 radians. Just a little bit longer than what the radius would be. Does that kind of make sense? That's what the radian measure means. So the angle is here. But when they're talking radian measure, they're still saying it's still the angle, but it's the length that's created by that angle. All right, so we're going to convert from degrees to radians, radians to degrees. And you did this last year. So how many radians are in 90 degrees? The biggest thing, it's always going to be pi and 180. What are you going to? What are you coming from? Are you going to degrees from radians or to radians from degrees? That's what you determine what's going to be on top. So if I have 90 degrees and I'm going 2 radians, the pi is a radian, the 180 degrees. Okay, we're going 2 radians, little r. The degree measure should cancel. One should be on top, one should be on the bottom. All right. When you are converting, they're going to ask you for exact radians. In Math Excel, sometimes they may ask you to approximate radians. So if they say exact, do not use your calculator. You are reducing in your head, or reduce the calculator. Do 90 over 180 and reduce it. It's a 1/2. And then you just put the pi on the top, right? If you're going from degrees to radians, you just flip it. That's a radian. You're going to multiply it by degrees from going from radians to degrees. So we have to have a radian on the bottom to cancel it. If these are exact already, the pi's should cancel. If the radian is approximated and it's in as a decimal, then you won't have a pi to cancel. You'll have to use it in the calculator. Okay? Mm-hmm. Okay. So what are you going to? If you're going 2 degrees, that 180 degrees should be on top. If you're going to radians, the pi should be on top. Okay. Again, that radian measure is simply turn around the circle over again. Okay. We're in a unit circle. How many radiuses you're going to go. All right. We ready? Okay. The arc length formula. Before anyone asks, I have no idea why the arc length formula is an S. It's the radius times theta. That's a symbol for angle. So theta is like our angle with an X. Okay. The angle has to be in radian measure, because you're doing arc length. Okay, it has to be a radian measure. It's an easy formula. So find the length of the arc intercepted by the central angle of 1/2 radians in a circle of radius 5. Well, the radius is 5. They tell you the angle is 1/2 radians. You're done. 2.5. You have a radius, you have an angle measure in radian form, you just multiply them and you're done. Pi over 2, 2.5. The next one, find a radian measure of a central angle that intercepts an arc length of 6 pi over 5 in a circle with a radius of 2. They're giving you the arc length, so please pay attention to what they're giving you. The radius is 2. They're asking you for the angle. So how do you get rid of the 2 there with theta? Just divide by 2, right? So remember, when you divide and you already have a fraction going on, it just goes in the denominator. So 6 pi over 10 would reduce to 3 pi over 5. And you want to leave that as an exact radian measure. You shouldn't be using your calculator. If you do, you won't get it to frac again. Okay? Let's just do one more for fun. Okay. If you finish writing that up, I'll make that a problem. Okay. So find the arc length of a circle with a radius of 8 and a central angle of 50 degrees. Okay, so, think about that. Here's my circle. They're asking you, hey, how long is this right here? That arc length. So here's my formula. The radius is 8. My central angle is 50. So that means it's 400? You have to have it in radians, right? So this is a degree. So right here, you've got to convert it to radians. So we're going to use that conversion. Pi over 180. Leave the pi out of your calculator. Don't touch it. This is 400 divided by 180. 40 divided by 80. 20 divided by 9. So 20 over 9. With pi on top. So 20 pi over 9. Okay. You do not want that as a decimal. Pi always is in the numerator. Okay. If you need your calculator for that, it would be 8 times 50 divided by 180 and then frac it. Do not put the pi in. Finding the distance between Tannerville, that has a latitude of 32 degrees and 43 minutes, and Tylertown with a latitude of 47 degrees and 54 minutes. Assume that their longitudes are basically the same, so they're directly north and south of each other. I've visited these places. The Earth's radius is 3,960, so find out how far apart. So again, we've got this world that is round, unbeknownst to some people that are confused and think it's flat. All right, so we've got this guy as 47 degrees, 54 minutes, and this is 32 degrees and 43 minutes. So the first thing we have to figure out is, what is my central angle? What is the central angle here? How do you find it? This is how far apart they are, so we can just subtract them, right? You're finding an angle distance, if you will. Subtract them. It's a 1, that's a 1, that's a 5, and that's a 1. 15 degrees, 11 minutes. And this is just an arc length. We are looking for this distance around this curve, so it's an arc length. Arc length formula, very, very easy. Radius times theta in radian measures. So my radius, 3,960. My angle is 15 degrees, 11 minutes, and we have to convert that because it's a degree. Now, over here, we left our answers in exact form. We left the pi's in there. Those are more theoretical questions. If somebody's asking you the distance between two cities and you answer with pi, I mean, you are the biggest geek, right? So you don't. Go ahead and multiply it through. Use your calculator, multiply it through. So, type it in. Sheldon from Big Bang might. But probably not. I don't know if he's that big of a. So, please practice typing in your degrees minutes. Make sure you can do that. And use the pi on your calculator. Do not use 3.14. This is approximately 1,049 miles. Okay, not a hard question. The difference between the latitudes is going to be your angle. All right. Now I'm going to do a little sidebar, just to see if you guys can do something. And then if you really understand math, you can. But I don't know if you've ever been taught it. Without using your calculator. Subtract them. Okay, so you're used to the base 10 where you can borrow. Remember how you have to borrow without the calculator? So if I have these decimals, let me show you the difference between them. You say, oh, I got to borrow 1 from this and make this 15. I have to subtract. I have to borrow 1 from this and make this 10, and I have to subtract. Yeah? We're not in base 10 here. If I'm going to borrow from this to feed this, how many of these are in one of these? 60, right? So we're going to borrow a degree, and that's going to make that 60 plus 15 is 75. Now you can subtract regular, because these are in base 10, and these are in base 10, but when you're borrowing from minutes to seconds, you're not borrowing 10. Okay? Does that kind of make sense? So now I can borrow here like I normally would. Okay. Same thing if I said I have 5 feet and 10 inches. Let's make that a little smaller. And I'm subtracting 3 feet and 10 inches. And you go to borrow. How much am I borrowing from this? What unit? How many of these are in this? 12. So when you borrow, going from unit to unit, you got to think about that. Does that make sense? You can use your calculator and do this. But truly, should you have to be. All right, so here we go. Slice of a pizza. So here's my pizza. And we want to know the perimeter of this slice that is 60 degrees. Radius of 7. So we're looking at arc length. We need to figure out this arc length. So you guys figure that out real quick. Use your calculators, because again, we're not going to give a pi answer for this. And again, if you're getting 420, that's a huge, huge pizza, right? 420 inches on the edge? What are you forgetting if you're getting 420? You're forgetting to change it to radians, right? Some of you guys are like, what are they laughing about? That's how I know the kids that are angels and the ones that are just little devils. Okay, multiply this through. 7.33. Is that the perimeter? No, that's this piece, right? We're taking this little pi wedge. So this is 7 and this is 7. So 21.33 would be the perimeter. You have to add all 3 sides up. Okay. Make sense? All right. Here's a running track. Here's where math is used. So how many of you guys run track? Okay. And you know, some people get to start ahead of other people. It's not because they're slower, right? It's because they're in an outer lane. So this person is going to run longer than this person. So you have to shorten the track for them. And it's not just, you know, Mr. Smith going out there going, we'll start here, right? It's very specific. It is that measurement, that arc length difference that they start you at. All right, so we've got a radius of 33 for that circle and 34 for that circle. So all the way around, what's the difference? So the arc length for the big circle is 34 times. How many radians do I have in a whole circle? Which is what? 360 degrees. Let's do this. 360 times pi over 180 equals, let's cancel to a 2. So the whole circle, get it in your head, guys, is 2 pi. Remember, it's the circumference of a unit circle. 2 pi, 6.28. So let's use these. Let's just kind of leave this in exact form for right now. That's the big circle. And the second arc length, we have 33 times 2 pi. So the difference between these two is 2 pi. So it's approximately 6.28 meters. The one kid starting ahead of the other kid. Very precise. Thank goodness we have math, or track wouldn't be fair. Okay. This next one, I would maybe write down, unless you're real good in science and you did this and you're like, yeah, I'm good at it. I forget what this is called in science. We're going to convert. He has wheels that are 36 inches in diameter. If the wheels are rotating at 630 RPMs, find the truck's speed in miles per hour. Well, if I have 36-inch diameter, what's my radius? 18. So remember, we're looking at a wheel. Here's my wheel. All the way around would be one rotation. Yes, one revolution. What's the distance this guy goes all the way around? It's his circumference. So C equals 2 pi times R. So the circumference is, I'm going to leave it like that because that's kind of what I want to. And this is how many inches this guy goes per revolution. We got to convert that to miles per hour. So let's start. They told me I have 630 revolutions per minute. I know the 630 revolutions goes on top because I have a revolution on the bottom here. They have to cancel, yes? Now, I'm in inches per minute right now because my revolutions cancel. So I'm in inches per minute. I have to change the inches to miles and the minutes to hours. What do you want to switch first? Inches, okay. Does anybody know how many inches are in a mile? No. How about feet? How many inches are in a foot? 12 inches in 1 foot. Where would I put the inches? On the top or the bottom here? The bottom, because I have to cancel the inches. So the 12 inches are on the bottom for 1 foot. Then we have to convert feet to miles. Again, my feet are going to be on the bottom, my miles are going to be on top. How many feet are in a mile? 5,280. You need to know that because this is a test question, and I'm not going to tell you on test day. So you need to know 5,280 feet are in a mile. So right now, my revolutions are canceling, my inches are canceling, my feet are canceling. I'm in miles per minute. Last conversion, I got to convert minutes to hours. So my minutes are on the bottom here, so they have to be on top here. There are 60 minutes in 1 hour. So if you go through and cancel, revolutions cancel, inches cancel, minutes cancel, feet cancel. I am in miles per hour. You've got to make sure you have the units canceling top and bottom. And then you're ready to pick your calculator up. You have 2 pi times 18 times 630 times 60. Those are all the numbers on the top. We're going to put that in a big parenthesis. Divided by 12 times 5,280 on the bottom. 67.5, so it's approximately 67 miles per hour. Okay. It's bothering me that I can't remember the name of that when you have to do all the conversions. Huh? There you go, dimensional analysis. It's just making sure you put your units in the right spot. Okay? All right. Almost done, guys. So close. So close. Navigation. So when you're talking about course or bearings, it's always from due north, which I hate because our trig is always from due east. This is where 0 degrees is in trig. But when you're talking about bearings, this is where you start. So your degrees always go from the north. Okay? So that's not really hard. So that's your compass. This is 0. What's northeast? Well, let's see. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 sections in this compass. So how many degrees is each section? 360 divided by 16. What do we got? 22.5. So each section is 22.5 degrees. So if I'm looking at northeast, how many sections is that? 2? So that's 45 degrees. That's all they're wanting you to do. Okay? Is that right? No, I said 45. It's a long break, guys. I'm even functioning today. It's a bonus. So I have to take tomorrow off. I just can't do it. I can't do 2 days in a row for a break. It's too much. Okay, find the angles and degrees that describe south-southwest. So that's here. Well, how many degrees is this going to be, guys? 180 plus 22.5. Okay. What compass reading is at 292.5? Does everyone know that this is 270? Right, each little quarter is 90. So 270 plus 225 would put me at here. West, northwest. So when you're looking at compass and directions and bearings, it's always from the top into the right side. Good enough? All right. So tomorrow,